Good evening, folks. Welcome to the Kubernetes July 2022 meetup. Before I hand it over to the speaker, so today we have Vinay and Ranjit over here who are going to be talking to us. But before we get to that, I just want to talk about a few things. This is a monthly meetup that we do every month as part of we used to do theme-based meetups, but the online meetups that we are doing currently are not theme-based. Also, we are on Twitter. If you haven't followed us over there, you can follow us. The handle is K8SBLR. A few points before we get into the main talks is please maintain some decency while commenting. If you have criticism, please provide constructive criticism to the speakers. You can post your questions in the chat section or you can raise your hand. So the speakers will either address you in between the talks or they can take the questions at the end as well. So if you have any questions or any sort of discussion, please post them in the chat section and the speakers will get to the questions at the end of their session, right? We are also recording this meetup, so we will be posting the link to these recordings after the meetup. So we'll be posting it on Twitter. So do follow us on Twitter. We also post updates and the presentation slides and everything over there. So Twitter is a great way to stay in touch with us, right? So further, I'd like to hand it over to Suraj to introduce our first speaker for today.
Sure. Hi. Our first speaker is Vinay. So Vinay works for Red Hat. He brings over 20 years of experience in various technical roles, driving partner ecosystem and emerging technologies based on solutions and architecture. He's an open source enthusiast currently, like I said, at Red Hat, where he manages the ISV and emerging technology partner ecosystem. So yeah, over to you, Vinay.
Hey, thanks, Suraj. Thanks, Prakash. Thanks everyone for joining us. I know it's not easy for us to join on a Friday evening. I now know why we're techies versus social outcasts. Right? We all have to be out there on a Friday evening, probably grabbing our mug of beers, but we're here, so I respect that time, and hopefully we'll spend the next few minutes and try to share whatever we've learned as a part of pulling things together and helping our partners build with new things and new emerging technologies. So on that note, let me quickly share my screen and we'll get started.
Yes, it's fine.
Prakash, can you can you please confirm if you're able to see my screen?
Yes, we're able to see yes.
Perfect. And it's in the presentation show, not the presenter view, right?
This is fine.
Okay. Yes, sir.
Perfect. Thank you so much. Welcome again, everyone, for the Kubernetes and Openshift India community. My name is Vinay Rajagopal. Like Suraj mentioned, I'm responsible for the technical relationship with all the ISV partners and try and help them adopt and build on Red Hat stack, bring them everything that is required to put together their applications, package it, the way they deploy it, and so on and so forth. And today's topic is going to be something very interesting. I know a lot of application developers would be excited out there who've joined us today. So we'll be talking about pretty much a service which kind of acts as a virtual application network, which then enables us to build a secure communication across Kubernetes cluster. It could be OpenShift, Kubernetes, and so on and so forth. And then how it basically talks to each other without exposing, let's say, a VPN setting or a port and so on and so forth. And we're all talking at the layer 7, right? The application layer. Now, the way we put that together is, that we will start with a quick, a look back in terms of where we were and how the whole thing has evolved, right? In terms of right from the Java messaging system to the Apache's project in terms of bringing the brokers versus what we call the routers now, right? And then we talk about the importance of the same thing, the fundamentals, which which needs change because the current era is not the same, right? We're talking about cloud native, cloud applications, applications which are distributed, and there's a need for us to kind of, keep them all running, right? And scale at the same time. So we're going to touch upon. So we're going to bring that essence back into our need of the current time, and then we're going to quickly do a recap of what we've looked through in the session, and then a very simple implementation of Scooper. It requires a multi-cluster kind of a setup. So what I've done is taken a few screenshots to just show you how it works, how you can implement it, and test it out. So that's what largely is what we're going to spend in the next few minutes. So just to go back, right? I'm sure all of us here, especially developers, right? They can relate to how we've started all of this, right? So if you go back to those days, when you were putting an application together, the client programming model was of significant importance for all of us, right? If you largely see, that's the model that is to help all the developers in terms of how clients will use the Java and the C APIs to interact with the message queue client, right? On a runtime. The part of the message service that is kind of directly accessed by client applications, using the broker services largely. But of course, you as a developer, you're supposed to take care of the connection services. You have to do the port mapper and the most the thread pool management, which is part of the overall JMS, right? So in simple words, we're looking back at how we all started building the old architectures, right? The message broker in a piece, which is typically a piece of software which enables services and applications to communicate with each other using messages, right? And now we saw that happen, right? We've been using, and then came the Apache Cupid project, right? And that's where we all had brokers. So predominantly it was broker which was trying to orchestrate, which message goes where, and if there's a failure, the broker holds on to that message and so on and so forth. Right? But then we realized it was not scalable, right? It was very difficult to manage it. We had to put in a lot of codes to kind of, route them to the appropriate brokers, right? So it became very challenging. And that's where it then gave way to designing a federation, somewhere where we can federate all those brokers and, kind of allow the messaging network, the underlying network, to be defined in terms of where one broker, the source broker, and to the destination broker, and how I would route this very defined between several exchanges, because it could be more than one broker, right? So from that emphasis, right, we saw that the message routes were very unidirectional, and we had to create one route every time there was a need, right? So from there, we all realized the importance. We all wished we had something like a router, right, which is capable, which is self-capable of routing those messages. So from JMS to all the way to the routers to the brokers, the need is something that we've realized, right? But for decades, right, for many years, we've always seen the messaging approach to be very towards the application integration, which was largely from proprietary vendors, right? Each vendor had its own messaging API. They had their own wire protocol. They had their own, their own troubles that come along with it, right? Because none of them used to, they were not interoperable, right? So imagine each web server vendor using its own protocol. That was not easy, right? So giving that situation, I know at some point of time we had this, Java, the JMS APIs, right, that were introduced, and things got a little better, I should say, but wasn't easy, right? And that's when we all wished we had a protocol which could dynamically discover the services. It's able to route it in such a way that it can optimize the path which is like the open shortest path that it can send those packets up. And at the same time, fault detection and recovery, right? Because you don't want to lose those packets. You lose those packets, you lose the data, then there's no purpose of, getting the desired action that you probably are taking on your application, right? So having said all of that, we were glad, of course, AMQP came into picture. First open standard wire protocol, thanks to Apache Foundation. So that's how it all started, and we're pretty happy. But is that where we are right now, right? Is it still something that kind of gets us where we want? Probably not, because the current era that we are in right now is not what it is, right? So how does it change, right? Why was it important for us to look at much more alternatives, right? Not just at the level, right? That's where the qubit dispatch, the router came into picture, right? And what that meant for all of us, specifically the developers, that you were able to link those routes, you were able to build auto links based on the shortest path, like I said, right? Which meant you could apply certain policies, you could you know exchange and bind a service towards it, and then control that entire thing, right? So it's like a very arbitrary topology with certain restrictions, and you also bring in a lot of redundant links to ensure, I mean, that there's no high availability aspects, right? It's like if I don't have one link, I move to another link, so you should have redundant paths there, right? The best part was you were able to reroute it, you were able to configure various address semantics that you could be using for addressing it, right? So much more border coverage. And of course, from a runtime and in terms of querying, looking at the management tools, understanding what is the status, understanding the reports, and so on and so forth, all of that became so important, and that gave path to the dispatch router. And dispatch router apparently has been told, I've been told, was in a naming convention that was used by railways. How do I dispatch a certain train at a certain schedule, and so on and so forth. So that's how our IT application gurus picked it up. So that gave path to the dispatch router. I'm sure you guys would have had setting up the router daemon, the conf file, also looking at what we had, the QD stat, right? Those days, which is to give us the router statistics, and the QD manage, which is to help us manage the router. So life was good until then, right? But is it the same now? Definitely not, because we're talking about new use cases, talk about edge use cases, right? Talk about multi-cloud, and talk about having applications which are built cloud native, right? Because these parts of applications are very distributed across different pieces of network, right? Which is very distinct in its own world, and all of these various parts need to come together, work together, behave as one reliable application at the end of the day, right? They need a way to kind of communicate. They must be able to tolerate failures, and all of that. And the modern large scale distributed cloud native applications cannot be monolithic, right? It has to be microservices and so on and so forth. It has to support multi-protocol. It cannot be tied to a certain network layer where you'll be dependent on controlling your firewall rules, go to the ACLs, make those changes, make the port available, and so on and so forth. Can we make it safe and secure at the same time? Don't expose the port or the VPN settings and so on and so forth to the internet, right? So that's where the questions came in, and that's where the Scooper, the virtual application network, came in, right? So we've kind of realized how we've evolved, right? And why there is a need for us to build on a virtual application network. Now, having said all of that, let's now spend time in terms of understanding what is Scooper quickly, and then do a quick implementation. So I'm going to the next part of the session, which is how do I really connect? How do I interconnect the applications across, let's say, multiple Kubernetes clusters, right? So we all know a single cluster is always a paradise, right? It's pretty straightforward. You have an application in through APIs, you expose the data in everything that you want to do in terms of the triggers or the application requirements from through a database, right? But when it comes to multi-cluster application, it's not easy, right? Why is it not easy? Because when it's a multi-cluster application, you're introducing layer 3 in between that, right? Like, let's take an example. Let's understand what these connectivity challenges are, right? So let's say you have a public cloud, you have a private cloud. Now for things to talk to each other, you need some kind of a connectivity in between, right? Now take that to, you remember I mentioned about edge, right? Now take that to a edge kind of a setup where you have this very small compute footprints at several distributor nodes, and you have this one public cloud with where you have your master plane that has to kind of control and connect and provision an application or decommission, all those stuff that it has to do, right? So we all need connectivity there, right? Now, in reality, what it is, right? You establish a virtual private network, you then, through the API or through whatever actions that you take on database, you connect to that. But is that what it is, right? I mean, if you look at it from a layer 3 perspective, you have to go through a lot of things, right? It's not something which is flattened, right? It's not easy because you have to do your configurations. You have to get your configurations right. You have to get the IP addresses right. You have to get your route tables right. You have to get your firewalls in place. You have to know which your ports and so on and so forth, right? But that's where the difficult thing is. Now imagine the same with where you will have to talk to a private cluster. It gets even more difficult, right? So how about having something in between where it can flatten the entire network, right? Can we really think about, other options to come out of this really complicated scenario of going through a lot on the layer 3, the network side of it, right? And that kind of reminds us, all of us. I don't know how many of you guys here, kind of relate to the Star Wars characters, the Yoda, the Ghost, the Jedi Master, Skywalker, and all of them. But the way it is like, imagine the two different worlds, and you have this service network right in between, which can, bring that magic sauce where you don't have to really do anything on the VPN layer, anything on the firewall, ACL, rules, setting the ports and so on and so forth. So that's the beauty. So if we have to translate it from a developer perspective, so we're talking about a service network, which is an abstraction layer between the network and the application services. So we're talking about layer 3 versus layer 7. Everything that we do on the WAN is on layer 7. So what that means to application developers are that your application, you don't have to change anything. You don't have to modify anything on it. Let it be HTTP or REST, or the way you expose the data, way you connect with the API, or your various JDs, the database related actions that you want to take on through your application. So what that means is it's no changes required. You don't need privileges, right? Elevated privileges. You don't have to be a cluster admin and all of that, and you could still achieve that independent of the network topology. So everything on layer 7, like I said. So just a quick definition so that we know what it is. Cooper is a layer 7 service interconnect. It enables secure communication across Kubernetes clusters with no VPNs or special firewall rules. So that's what Cooper is all about. Now let's look at it from the cluster perspective, right? Again, going back to the emphasis of the single cluster, right? Now, if I have to expand the way when you initialize Cooper, the Cooper infrastructure that gets built is basically, it is a proxy, and it defines a virtual service along with the proxy. So these are not sidecars like you typically see in the service mesh. These are proxies with the virtual services. What that means is it initializes the Cooper at both the sides of the cluster, and then that behaves as a WAN, the virtual application network. And that routes your packet, that routes the data and gets you whatever you want to do in terms of the application actions that you would take across the clusters. Public, private, doesn't matter. Yeah, of course, it's a free open source software, Apache Foundation, implementation of WAN. It has your Kubernetes and Docker local services. Again, it's all extension of what we've seen. So Scooper essentially is a router. And what we've seen all through the generations, right? The Cupid dispatch router, that's exactly what it is, but it very lightweight, very small footprint. And like I said, it doesn't use sidecar. So and for those who don't know, it's quite mature. It's been 6+ years now. So that's what Scooper is all about. Now, the most important one, let's do a quick recap. The most importantly, a simple implementation of Scooper. So the most important part of the session, how do I deploy application services across multiple, how do I deploy and make sure they connect and they're able to speak to each other across multiple Kubernetes platforms, right? So quick recap, layer 7 interconnect, I'm sure you all understood that. What it does, enables secure communication between Kubernetes clusters, allows connectivity between data centers and cloud providers, which means it's a true hybrid stuff, right? Very simple to set up. I'll show that to you guys as a part of the Hello World example. Does all the smart routing that it has to do. And what it means is that you could pretty much build here and connect to anywhere, any of your hybrid approaches, any of your public hyperscalers and so on and so forth. So Skype routing, get ready for the quick implementation. So what we've done is we've taken a simple example here where we will explore, and it's available. There's of course the link, the GitHub link in the slides, which we will share with all of you. So what we do here is basically there's a front end and a back end split between 2 Kubernetes clusters. Of course, we could have done 4 or 5, which I couldn't. That's why I've taken some of the screenshots that are existing that I kind of put it together for you guys. So Scooper, what it does is create a virtual network between these 2 clusters, cluster 1 and cluster 2. And in each of these missing services, you will see that virtual services comes up, the proxy thereafter, and then you annotate the service, and then you'll be able to see the packets. I mean, you'll be able to communicate between these various clusters. Now, what we've done here is created 2 namespaces here. You see one for West and one for East. And we set the whole context here. Now, the one very important thing that you will have to kind of notice here is that, when you initialize Cooper, you actually save those configurations, those properties into an YAML file, right? Usually, the best practice is you take the cluster name and then you save it, and then you could then SFTP it to another cluster, which means that it will know what are those properties for me to connect. And it's very important for one to, when they initialize it, either they add an ID to it, some kind of a name representation, and that YAML file is something that you don't want to expose it, right? Because it has all your configurational requirements. And that is where the token is created, right? And the need for the token is then that you can apply that token to another cluster and connect to the other cluster using that token. So everything that goes, once you initialize it and once you create a token, you save all of that information in an YAML file, and you then use it to connect to the various clusters based on your business, the application topology, right? Now, once we've done that, we've created a token. Once we've created a token, you attach it, you connect using that token to another cluster, right? So in this example, you see a front end and a back end deployments, right? And then front end deployment is exposed to the incoming traffic, right? To the back end. And now, once you've done all of this and you go to get services, right? Shows you all the services, right? Now you will be able to see that all of them are connected, right? The entire scoop. So the Scooper router is the infrastructure, and you see that it's connected to various, all the 2 clusters that you have built here as a part of your demo. Now, to quickly summarize, Scooper allows you to create virtual intercluster network. And the best part it is that the communication is via virtual TLS, right? That again means no VPN settings, no firewalls, like I keep saying. Scooper applications can span multiple clusters. You saw that. It doesn't mean it could be a cluster on the data center. It could be a cluster on a cloud provider. It could be a cluster on anywhere. It doesn't matter, right? So the best part is that it's without exposing the service ports, right? You don't have to really care about what is the port number and etc., all of that, right? So what that also means to us is that the network, the application as such, doesn't have to worry about communication, because it underneath what Scooper does, it builds a unicast and a multicast way of transmitting the data. So one doesn't have to worry about it. One doesn't need to have elevated admin privileges. Everything is handled transparently, including your HTTP1, HTTP2, and also the various traffics, right? The TCP traffic and so on and so forth, including gRPC. I haven't mentioned it yet, but that's also possible. So it's all secure by design. Again, you're not exposing no VPN, no firewalls, and all of that. So it makes it pretty easy. But what you also want to importantly look at is the fact that for an application developer, right, a lot of things becomes absolutely easy here. Yeah, that's the last slide. So absolutely easier to to bring these aspects into your application design, and easy to enable communications across any of those clusters. A true hybrid potential possibility. That's it pretty much from me. Suraj, over to you. Doesn't look like my mouse pointer is okay. I got it.
Well, if folks have questions, you can use the raise hand feature and we'll unmute you. Or if you prefer typing, okay, I guess that's fine. If not, then I guess we can move to the next talk.
Will we take a break for 5 minutes, Suraj?
Oh, sure. Yeah. Oh, okay. There is one.
Yeah, I think we.
Yeah.
Or maybe a few minutes, right? It's 3 minutes.
Yeah. Can you ask the question now, Machindu?
Yeah. Hi, Vinay. Thank you for this nice presentation. Actually, I'm very new to this Scooper topic also, and to the Kubernetes also. So I don't remember if anyone is in my contacts using this Scooper. So how is it using? Is it now secure to use Scooper in our productions as well? Can we use it?
Yeah, good question. Yeah, I mean, there's a lot of things, right? For example, if you're new to Kubernetes, I think that's the first place that you want to start, right? The hardening a Kubernetes cluster is not easy, so you probably want to start there. If you're looking at vanilla Kubernetes, or being a Red Hatter, I would always say look at OpenShift. So if you are looking at OpenShift or Kubernetes, start from there, because there are a lot of things that you will, from a cluster level, that you want to take care of from a security perspective. And then, of course, once that is there, Scooper would be something that you could definitely go ahead and try it in your dev, and of course in your production setup also. There is dynamic load balancing, service capacity. You can, with Scooper, the thing that I like personally is you could make it something called locality aware, there is cost emphasis in terms of forwarding the traffic, and like I said, there is for network failures, you have to come up with a lot of redundant routes, because that then gives you that ability to be safe and fault tolerant and things like that. So Yes, why not? But start with Kubernetes, please, since you said you're new to everything.
Dhananjay, you got a question? Raksha. Mute.
Yeah, I just wanted to ask actually, does the data remain secure because there is no any routing and all that thing? So how does the data is being secure while whether the data is secure while the data is in transit?
Yeah, so the good part is you're not exposing. It's like I said, MTLS, right? Mutual TLS. The best part is you're not even exposing your ports and all this. So there's no way people will find a way to get to your network, right? See, the about 60 to 70% of data exposures that have happened is because of people knowing your properties, your configurations, right? It's always either someone in the within the network that ends up exposing something which he was not supposed to expose, and then leads into data leak and so on and so forth, right? So with this, I think the best part is, since you do not expose the VPN settings, you do not expose the ports, even as simple as ports, right? Why would someone needs to know? So that way, the connection between the clusters becomes absolutely secure.
Hey, Vinay, I have a question. So I think I read in one of your slides that you spoke about you don't need admin privileges to set up Scupper, right? So can you just talk a little more about that? Like, how does it set up, and how is the cluster, I guess, safe from being compromised from that respect?
Yeah. So the good part is you don't tie it to a particular namespace. You don't tie it to a particular project, right? And that way, you need cluster admin when the roles come in, right? Where you want to kind of differentiate or kind of isolate between XYZ projects, XYZ namespace within your cluster. With this, it is made available across. And the beauty of that is that, if as long as you have the token ML file and you distribute it to the various clusters that you want that to be connected, the even the topology changes. In the networking, the world of networking, if the networking topology changes, everything falls flat. But right now with this, even if the topology changes, nothing will happen. So the cluster admin role is not required, because you're looking at a layer above the roles perspective, because end of the day, the clusters have to connect to each other and communicate to each other. Therefore, you don't limit it to a certain namespace. You don't, and therefore there's no cluster admin user privilege that is required.
There's one question in the chat.
Hi there. Maybe, yeah, I could read that out in the benefit for everyone. Can we use a role-based access to database backend with Cooper? I haven't really tried it out. The whole purpose was to see whether it enables a safe, secure connection for in between the clusters. But that's a good question, because both your API or your database stack can be. We should be able to kind of inherit the roles that comes. Though it is not required, you could still inherit the roles that comes for our back setup from a cluster perspective. I think that should be possible, but I haven't tried it out. Something good for us to try it out and probably demo it in the next meetup.
If there are no questions, maybe we can wrap this up. Yeah, sure. The recordings will be available. Can you hear me, Prakash?
Yes, we can hear you.
Yes.
Okay, then let's continue, right? You don't have to take break.
Yes.
Okay, hi all, I'm Humble Charamal, co-organizer for this meetup group. Thanks all for joining us today. Let me introduce our next speaker, Ranjit Rajaram, a colleague of mine at Red Hat, a long-time Red Hatter. So he's also an active member of several open source groups and a speaker at various conferences. And he's also an organizer for DevConf. He has 18 years of experience in implementing Linux servers on complex workloads, currently concentrated on container space. Let us welcome for his next great talk on Microshift at Edge. Ranjit, over to you.
Yeah, thanks a lot. Welcome all. I'm sure that I'm between you and the beer now. So let's take a quick look on the project which is known as Microshift. Since Humble gave a very detailed intro about myself, I think this slide seems to be duplicate. Just to reiterate, my name is Ranjit Rajaram. I've been working with Red Hat for 16 years. I basically do product support. I've been a speaker at several conferences, been a speaker at the KubeCon as well. All right, so what is the things that I'm going to cover? I'm going to cover about Microshift, and I'm going to talk about what are the features about Microshift and why you should consider if you have such an use case. And on top of that, I would also cover a few things which are not directly related with Microshift, but which kind of enables the project. Okay? And also, I have a certain demos, so I might be switching between the slides and the slides and the demo quite often to explain certain things. I hope I'll be slow enough so that you can follow me, right? Now, what is this Microshift, right? So the Microshift is a research project that aims to optimize how we can use the Openshift OKD on a small factor devices and also for the edge computing. Right, so it aims for small factor device. So that's the important part, right? And the thing is that edge computing doesn't mean that it is always small factor devices, but in the Microshift space, we are going to look at edge computing as a small factor device as well. Right, so in terms of a resource procurement perspective, we're just going to compare Microshift with the other similar offerings that we have within the Openshift space. Let's look at the Openshift Local. So it was previously known as the code-ready container. So the minimal, so it actually helps you to set up Openshift on your laptop. And it is not a production-ready stuff. It's just for you to try out Openshift and prepare your, and it helps you to develop your application. So the minimum amount of RAM that you need is 9 GB RAM, and you actually need 4 virtual CPUs, and it also needs virtualization support, which needs to be enabled. Right? Then we have the single node Openshift implementation. So this is actually a pretty huge. It is just the Openshift as single node, but still it requires 8 CPU and 32 GB of RAM, which is the minimum host requirement. Now let's say, for example, so there is a lot of gap that which is there from the Openshift space to target a small factor device. Right. So now to help people to adopt or to use to get the same features of OKD that right. So how can we have the same thing on a small factor device, and how can we optimize it, right? So the Microshift, as I said before, it is aimed for small factor device, so like 2 core CPUs and 2 GB RAM. And the Microshift binary, which is the only single binary that we need, is close to 150 MB. Now, there are other CNCF projects which are there, like the K3S, which are quite popular. So there, the binary binary itself is under 50 MB, right? But you can really compare with Microshift and the K3s because there's a lot of additional APIs that we kind of extend on top of Kubernetes, which makes it OpenShift, right? Yeah. So how do we reduce? So how did we reduce the footprint so that it is so that you can deploy Microshift on top of a small factor device? Right. The first thing that it's been done is completely the cluster operator feature has been removed. Right. So when we say it is removed, you can still install what you need. Right. So when you do that, you should keep in mind is that you would need more memory. Right. Then the other part that we did was we completely removed support for the third-party storage drivers and support for cloud providers. So if you look at OpenShift, you could just run a single command and you can install the entire cluster on top of a cloud provider. So those sort of features has been removed. And then what we did is we combined several processes into a single process. Let's say, for example, the process examples are right. So when you deploy an OpenShift OKD, right, you actually have a CD as a separate container. You have an operator. You have an processes. Right, you have Kube scheduler. You have OpenShift API. So these all processes has been combined into a single process. So there are some pros and cons when you do that. But to meet the requirement of a small factor device, we actually had to do this. That is to combine all these processes into a single process. So the advantage here is that the common code that is being shared between these all processes have been combined. So you may not have to, so you do not end up using more memory, as well as the sizes of the binary might be on a smaller factor. And then from the worker node perspective, also the same Microshift binary also combines the node features like the kubelet and the kube proxy. So all together, we would only have one single process running on the node. Then along with this Microshift process, to allow you to use the additional features that comes with the OpenShift OKD is that it actually deploys an Ingress controller for you. It also deploys Flannel, and in the future releases, the Flannel will be removed. It will be replaced with OpenShift OVN, and also we also kind of enabled KubeWord host path provisioner if you have any file that needs to be shared from the node itself. Right. So now these are the things that is mainly that. So this is how we actually reduce the size of the Microshift binary, as well as how you could install a Microshift on a small factor device which just has 2 GB of RAM. Right. Yeah. So now when you do all these things, that is when you combine these processes as a single process, you have removed a lot of operators. You have removed the support for the storage drivers. Does the Microshift lose the edge? Right. So now the things are taken into consideration that the OpenShift code logic or the operation logic is not lost. So to enable you to quickly deploy an application, the Ingress controller is also being configured for you. And we also have the code DNS also being a part of this particular package, right? And then the main team of OpenShift or the containers, right? That is develop once and deploy anywhere. So that sort of offering is still there, and so that is one of the main actually point of making sure that the OpenShift still the Microshift still sticks on to all those things, right? And you could use the same open cluster manager tool to manage your OpenShift OKD, as well as you could also connect your Microshift to those sort of central projects or to your applications from where you can control your Microshift cluster as well, right? And then the thing is that you could also configure Microshift to run as a master node, as well as you can also configure that to run as a worker node only. Right? So you just have to pass certain parameters So if you don't pass any parameters, it will run as a single node. That is both the master, the control plane and the worker node. The data plane will be on a single node. In case if you have a use case where one of your small factor device just needs to act as your worker node, you could just configure Microshift in that way, or you could just run it as only as a control plane, right? So it can run in an autonomous way as well. In case if you still want to, the thing is that you can still control it from outside, and then once you deploy it on a small scale, on a small factor device, you can use the OC and the kubectl to be controlled or to deploy an application the same way that you would do with any Kubernetes deployment. Right? Then here since I mentioned flannel as of now, so we don't so the pod-to-pod communication happens over the VXLAN like the old days. And everything, since we are going to deploy it together with an operating system, on top of that, we are going to deploy Microshift. So so we actually depend on the operating system to configure the networking in the host OS. Yeah. So how can you deploy what are different methods to which you can deploy Microshift? Right? You can deploy Microshift as a container, or you could package it as an RPM, and you could even use a tool like an image builder tool. You can create an RPM OS tree based on the packages that you actually give, and then and then you can deploy it as an image onto your device, and or the third point is that you can just deploy it like a custom application on top of your on a managed edge device, right? So these are different ways how you can deploy Microshift currently. So when you deploy it as a container, you could use the auto update feature of the Podman, or and then in case if there is a new Microshift container image available, you could automatically update your version, right? And if you're going to use the native way of using RPM and the RPM OS tweaks, then you have a much more better way how you can have a managed, controlled way how you can deploy Microshift on your edge devices. Yeah, and the Microshift uses customize. So what it means is that you can deploy your manifest files under these different directories. So the moment you create, or when you package Microshift, you could add some your custom application, your how you can register your small factor device to a central server. So those sort of applications, those configurations in a YAML format, you can place them in these directories. And once you have it in these directories, the moment the Microshift boots up, it will read them and it will do the auto connect, or it will deploy an application for you, right? And so the moment it reads it, it will do a normal kubectl apply. Right. So now we're going to look at the edge. Now edge, if you ask me what is edge, so edge brings the compute closer to the producer and the consumer of the data. So as I said before, we are talking about Microshift, so that's the reason why I have shown you a single board computer image, a board image. So the edge doesn't always means that it is a small factor device. It could be like a normal system which has tons of CPUs and RAM, which can really help. But there are use cases where you would need a small factor device, right? So now let's assume that this is a small factor device which you're going to deploy, and it could be the person who's going to install it could be a person who is just going to screw this system on top of a wall, or maybe on top of an antenna, right? He could place it anywhere. And now you actually need there could be a problem. What would happen if you have hundreds hundreds of small stack devices being installed and deployed, maybe at the same time, maybe at different times. And how do you manage all these things? So, I mean, one of the main factors is how do you keep track of, what is going on? Like how do you update these sort of these deployments, and how do you connect them to a central server? So there could be a lot of questions that would come to your mind, right? I mean, when you have such a small packet device and that's being deployed at a scale, right? So now we're going to look at something which is going to enable the Microshift, right? So now this is an image builder tool, which is based on the ArcStream project, which is known as the Lorex Composer. So using this particular image builder tool, what you can do is you can generate an image for the edge device. So what to do is, so when I say an image, it could be an OCI container image, it could be a QCOW2 image, or it could even be a tar file. So what you would do is you would package your Microshift binary, your custom, if you need to have a custom agent and monitoring agent, so you kind of build them as a small pack, as an operating system tree, and the end product is an OCI container image, right? So once you have this image, you could use your existing workflows that you have to deploy an Openshift, not Openshift, and Microshift onto your devices, right? So if you haven't used this particular tool, just try this once, because you can customize. So it is just not for Microshift, even you can customize your operating system build. Right? So for the Microshift use case, so we recommend, or I would recommend, the end, the type of the image that you're going to build is of a container image, right? So so without me trying to explain much, right? So the moment you have an OCI container image, you can you use your container registry to pull it up in your remote site, or you could package it into your, as a tar file, and you can just copy it and start it again. Right? Yeah. So this is just the workflow, just to show you how we are gonna ship the image, right? So as from the image builder, we would create an OCI container, then we would push it to a container registry, and from the container registry, any deployment can pull them, or you can use it to install by using a start file, or maybe you can even use an image file. That means you can just directly write it into the hard disk and you can start, right? So now when you do it as a container image, the thing is that, let's suppose you have deployed Rev version A1, and in case if there's an update, just not to the Microshift itself, but to an operating system bits, you can release a new OCI container image. Once that is released, you can just pull that image or do an upgrade so that this new bits are being pulled. And when the time is right, you can just simply do a reboot. So when you're going to pull an image, the existing libraries or the binaries are not affected, right? So that is the beauty of the RPM OSP, which we are going to see here, right? So the thing is that when you're going to deploy it as an RPM OSP image, and you do have built an OCI container image, which actually contains the operating system pre-contents. And then when you're going to pull it up, that particular image update. So the beauty of it is that the current running processes or the applications are not affected. It is just being pulled as an image or as a tree. Right? Only when you do the reboot, the newer binaries or the newer libraries will come into the action. Right? And then, so let's assume that if you are used to running YUM and APT gates, right? So there are situations where you would run into some sort of a dependency issues, trying to resolve, some sort of a package dependencies and things like that. But when you use this operating system tree, right, you would do the firefighting of resolving the dependency once, that is at the time of building the image. Once you have built that image, you can just pull that image to your node and just start it, right? So it will be a new tree. And then when you're using this RPM OS3, there are some additional advantages that, it will not save, if let's say, for example, if there's an update to if there's no update to a binary or to a library, it will not save that file. It will only just do a link, right? It will also save your storage space. And then when you're using this RPM OS3, I think with the OpenShift OKD version 4, the core OS is being widely used. And there, if you had a chance to, to lay your hands on it, so you would know that /user is where all the binaries remain, and it is kind of a read-only. So you won't be able to install or modify. There are still options with which you can do the install, but that is only for an admin, only if it is needed. And then we actually have the /var and /etc as writable. So when you move from, let's say, Rev A, the revision A to from A1 to A2, the changes that you made on /etc is moved forward, right? So even with the version A2, you would see all the changes that you made to /etc directly there. And then let's assume that, at the Rev A2, that is the revision A2, you still made some changes to etc. And then you move back from A2 to A1. And at that particular point of time, all the changes that you made to etc with version A2 gets lost, right? So you have to keep that in mind. So the changes that you make to etc are always going forward. Once you make a change, let's say, for example, version 2, and when you go back to version 1, the changes are lost, right? Then the other important feature that when you build an operating system with Microshift binary, and then you kind of deploy it on a small board computer devices. So those devices won't have a console or ways through which you can do any sort of a troubleshooting while doing an update, right? Because these devices could be on top of a wall or maybe somewhere else. And let's assume that if you are doing an update to the Microshift, and due to some reasons it is not working in the way that you desire, so you need to have an option to which you can roll back automatically, right? Because if there's a problem, your deployment, your application won't report back to the central servers, and then you would have to find someone to use the ladder and climb up and get the system connected and console and then do the troubleshooting. So that's not possible. So you need to depend upon certain projects like the Green Boot, through which you can actually roll back automatically to the last known working version, right? So this certainly helps when you try to do an upgrade, right? Right. So let's quickly take a look at the demo. And yeah, so when I say demo, I will be showing just a few parts of it. So first, right. So as I said before, you can deploy. I hope you can see my screen. If not, I'll just make it big. So as I said before, you can deploy Microshift as an container image. You can see here, right? So this is the container image, and then so what it means is that on your already managed edge device, you could just pull this image and start. And then the other important point which I told about is that the entire right. See the entire so we combined a lot of processes to run as a single process. So if you would see, right, you can see the entire Microshift, right? All of them listening to the known ports that we are aware. For example, the port number 2049 or 2048, right, which are being used for HCD. Then we know the 6443 is used for API, right? So so we combined a lot of processes to run as a single process. There are pros and cons. If one of those processes misbehaves, the entire the other process can also get affected, right? So that's the con. So the pros is that you can make it very small and get it ready for a small factor device. Yeah, and yeah, so the OC command works, right? So so let's say okay, there is okay export. Let's look at it a bit later. Okay, so now let's see. I mean, let's look at this. That is. Okay, so so what we did was, let's assume that you use an image builder tool. You build up. There are two container images that you built, and so those and on the screen you can see those two images, right? So this particular container image, they contain the entire operating system tool. Right? So what we are going to do is we are going to use one of this image to install a Microshift deployment on a virtual machine, right? So now just for the demo, I'm just using a virtual machine, and this virtual machine will only have 2 GB of RAM and 2 virtual CPUs. And so if you see that image for the process, so here we can see I've just started a container using the first image. So this is a very small script which I've just used to change the container, right? So what we're going to do is we just use that image. We started a container, and that particular container has an Nginx server, which is going to help you to install the Microshift on top of an virtual machine. Okay, and here you can see it is listening on port 8080, right? And to install this, what we are going to do is yeah. So to install this, to make it easy, so we are just going to use a kickstart.ks. So even the kickstart file, you can package it in the image itself, right? So the main configuration here is that at the time of install, here you can see, let me make it big. Right. So at the time of install, so this is the main important line where we are saying that, okay, go to this particular web, to this particular web server to grab all the contents so that you can install it on your, I mean, on your Microshift node. Right. So let's assume that this is an a small factor device, and you're going to install it using the same kickstart file, and it would hardly take 2 to 3 minutes. So while this is happening, let's look at okay. Okay, sorry. Yeah, let's see what is happening here. Yeah, so the install has started. So I'm just logging into the image builder server, where you could just take a quick look at how you can build an OCI container image which consists of the entire operating system tree. Okay, so now this is a cockpit interface, and within this cockpit interface, we have installed the image builder plugin. So here is the install which is going on. Since we have used Kickstart, we need not lay our hands on the install. It will be quick and easy. Right. So this is the image builder tool. And so what I've done is I've, mentioned the packages that is needed to be installed on top of, as a part of that particular operating system 3 image. It will take some time to list all the packages. So by the time the install is going on, and here you can see what it is doing. It is pulling up the operating system 3, right? It is just not doing any sort of an RPM install. It's just pulling up the 3 as an image, and it is writing as such to the disk. Okay, it's taking some time. Yeah, so there is some oops. That's fine. Since it is a cockpit, I will actually show you all the things that is happening on the system, right? So, okay, things happening. Awesome. Okay, so let's bring the slides back up. Yeah, and the install is being done. So I just wanted to show you a few stuff from here. So just to recap what we did, we built an OCI container image, and using that OCI container image, we have deployed a new Microshift cluster, which is going to be a single node cluster, and this particular image will have the Microshift binary. It will also have the OC binary, and it also be pre-configured for you to quickly run those OC commands. And the Microshift binary will take at least, let's say, 4 to 5 minutes for the entire cluster to come up. Let's see. Right? So right now, what you're seeing is we only have a single operating system 3 on that image. Right? So as I said before, this particular virtual machine just has 2 GB RAM, right, and two virtual CPUs. Yeah, so we are in. So the install is done and system has been booted. And right. So the thing is that it will take at least 3 to 5 minutes for the entire cluster to be up. So if you take a look at the service, the Microshift service gets started by the systemd as a systemd unit, and it has to pull some packages and the container image to which it needs to come up with the additional services like the core DNS, the routers, right? So if you see, like, so for the moment, there are no images or nothing, right? So now the Microshift is just starting. And at this particular point of time, if you try to, execute an OC or the kubectl command to see the status of the cluster, it might take a minute or two because it's not yet fully ready. So here we can see we just quickly installed it. That image already had the OC as well as the Microshift binary. It's a standalone server, and use an OC command to get to an OC or a kubectl command to see the status of the cluster. Right now, it is not ready state because it is waiting for the flannel to be pulled and started. Let's see where we are in terms of pulling that image. Yeah, so we are starting up. So here you can see it has pulled up the final image, and also, right, you can even package your open system 3 contents with these OCI images as well, so that the time to initialize my cluster can be reduced as well. Yeah, so we are coming up, which is good. So at this particular point of time, I hope we should be ready. Right. So now we are ready. That is, the cluster is ready. So it just needs to bring up the router and things so that you can access your application. Now let's quickly deploy an application. Right. All right. Okay. Yeah. So our first application on the Microshift cluster is a needs puller. Okay.
Access the spelling.
Yeah. That's fine. So let's see, right? So I think it's good to show a little bit of troubleshooting. Yeah, so the spelling is wrong. So let's delete the pod HTTP, because what it says is that I've given a wrong. It should be accessed instead of ACESS, right? So what is this image is that it will just simply deploy an HTTP image. And so it is as good as a normal cluster, right? It's the same. So now let's look at what would happen if you're going to deploy an update and that update has a bug or an issue with it, and how does the green boot service is going to help you out. As I said before, your end Microshift deployment nodes, which are known as the small factor devices, they may not even have a console or a serial device. So in some cases, they would have a serial device, but to connect to it, it might be a bit of a problem. And let's assume that you have thousands of small scale devices. So it's not possible to go and manually recover each and every one of it. So it is good to reboot the deployment back to the actual working thing, right? Yeah, it's still continuing creating. Let's look at the other, so OC get pods or OC get projects. So if you have used Openshift and in a default Openshift, you would see a ton load of namespaces. But when you type this on a Microshift, you can see how stripped it is. Right? We have stripped a lot of namespaces projects. We just kept it simple, just enough what we actually need. Right? And if you have an open cluster manager, which is an open cluster manager sort of an application, you can register this particular node to it as well. Okay, so now we have the first pod up and running. We also have the router pods and everything running. So here you can see the DNS services up. So it is like our normal cluster, right? Sorry. So this should be reachable, right? That's, for example, just to showcase that these are all working fine on a Microshift cluster. Right. So your application should be able to connect to to the pods which are running within the cluster, within the node, as well as it should be able to connect to an external pod as well. When I say pod, it could be an application. You could do a lot of connectivities, but the idea of Microshift is to keep it simple at the same time, you can still manage and observe your deployment like a normal Kubernetes cluster. And yeah, now let's assume that you're going to deploy a new version. Let's assume that there's some sort of a bug, and you have thousands of Microshift deployment across the globe, and you're going to release a new update. Somehow there was a human error. I'm sure that with the current CI/CD pipelines and things like that, you can avoid errors, but there could be a possibility of an error where your application is not working after the update. Okay. So what we did was we just ran a small script. So what it do is it will start a new container using that image which has the update, right? And here you can see it is gonna listen on the same code. So now when you install it, I showed you before. We actually mentioned which server to be contacted at the time of install. So when you do this, the Openshift, sorry, the operating system 3, that is the OS 3, will also configure that to point to the same servers, right? So now here, what you can do is to simply do an upgrade, right? So first, we can check whether there is any sort of an upgrade, right? So you can automate this also. The moment there's an upgrade, you can even configure your deployment in a way that it goes and pulls up the upgrade, right? It doesn't wait for you to run this command manually, but just to show you for the demo, I'm just running this command as a manual. So here, what you're going to see is it says that there's an update available for you, and the commit ID is 7F, right? So let's do an upgrade. So it says that there is one difference. Okay. Now let's do the upgrade. So now this is a demo where I'm just going to show you what would happen if there's a when you're doing an update and if there's a bug with the update, right? It's going to affect your application, and what should how the rollback happens to the previous known working version of the operating system. Right. So right now we have done the update. So if you see, right. So right now there are two operating system trees on the node. The symbol over here shows you that which is the currently booted one. So I just want you to take a look at the commit IDs. It is like the Git, right? Like the Git commit ID. So the one that is being updated, I mean, one which we are going to update the system to has a commit ID of 7F. One which has the current working update. I mean, the current deployment commit ID is 8. So 3BA, right? So now we have done that update. It shows us that there is one difference, which is we have added a new package known as the resolver. And to use that particular update, you need to reboot, right? And so now when we're going to do this, we're going to look at this particular screen to understand what is going on, right? So here I just recap. So I just did an update of the Microshift deployment to use the latest version, and to let you know that the latest version has a problem where the applications won't work. So I'm just going to highlight how the automatic rollback happens. So the reboot is done. So here you can see the node is doing a reboot. Yeah. So so at the graph screen, right, where just take a look at it. Yeah, there could be an a pod which is trying, which the system is trying to stop. So it is trying to stop a container. It will take a minute. Yeah. Yeah, so the reboot is good. It's going on, right? So the normal boot process. So here now what you're seeing is that we are seeing two OS3s, right? 0 and 1. Now the system will boot in the normal way. Yeah, at least for demo purpose, I could have added more RAM so that it might move faster. Yeah, so now the boot it's complete, right? Now let's wait for a minute. It will quickly do a reboot. It will throw some messages on the console. Yeah, so now the reboot is happening, right? So it will reboot 3 times, right? Why it is doing reboot for 3 times is because it actually is trying to recover the node to, if it is just a one-off case, right? I mean, maybe the second reboot it might fix by itself, right? So that is why it tries to do a reboot of 3 times. And when it fails the 3rd time, and at the 4th reboot, it will do an automatic rollback to the last known working version. Yeah, so you guys will have to wait for 2-3 minutes to see the switchover happening. So if you try to connect at this particular time to the server, right, you would see a wall message. Right? So the wall message says that one of your green boot script has failed, right? So this is a health check script that you write, and I'm not going to go deep into the green boot how it works, but you can deploy your health check scripts, as well as you can even write a systemd unit file that does the health checking for you. So when your system boots, the green boot service will also start. It will run these scripts, and the moment it detects that the script is failing, and depending on where you place the script, if you're placing a script in a particular location where it says that if that script fails, then you need to do a reboot, right? So that is what has happened. It says that the boot status is red, and it says an health check failure, and it goes for a reboot. Let's see now. Yeah, it has done the reboot again. Yeah, so why I'm showing this green boot is because when you're going to deploy, when you're going to use a Microshift for small factor devices, these are the things that you need to add while trying to deploy this as a project. Okay, let's look at our application. I think there should be one more reboot. So here you can see we did an update, we did a rollback, we did a lot of reboots. The pod is still up and running, which is good. So let's go back to the slide. I think that is the end of my session. Yes, yeah. Yeah, Humble, over to you. And if you have any questions, you can ask them.
Yeah, that was a great presentation, Renchit. Let's check, are there any questions from the audience?
Audience, if you have any questions, you can post them in the chat section, or you can raise your hands and we'll let you unmute yourself. I don't see any questions yet, so I guess we can wait for 1 more minute before we begin the closing. Right?
I think it was a crystal
If
clear
there was no questions, then it means that either you did not understand the word, maybe you understood
it was a really
everything that's
good It was a really good presentation.
Yes.
Yeah, maybe you can just
Humble, you should
clarify
ask the
that.
question just for the sake of it.
Right. Yeah.
Just,
So Ranjit, can you say the difference between OC and kubectl? Maybe we have been talking about OC a lot. So some of the audience.
so the difference between OC, we call it as an OpenShift client, same thing like a kubectl. If you ask me what's the difference between OC and kubectl, I really don't know, but I think it's the same. But I haven't explored to understand what would be the difference. I think it is as good as same as kubectl. You could do the same thing. So I'm sure that you can do everything that is possible with kubectl on OC. And with OC, there could be something more which I'm not aware. Right? I'm really sorry for that. But that's the answer which I know. Yeah. And I see a question on the chat which says, what type of applications we can run on small factory devices using OpenShift? Yeah, it is not OpenShift. We should say it as Microshift. Yeah, so that's a challenge. So that's a very good question, right? So we are saying that Microshift is designed for small factor devices like a 2 GB RAM and 2 virtual CPUs, right? So if you have an application that needs a little bit more RAM than what is actually there available on the node, so let's say for example you can run a very basic HTTP server which just serves static pages. And so that might be a good enough use case. But if you have an application that needs a bit more of memory, more of CPU power, then you need to look at either OpenShift OKD or Kubernetes or any other flavors, right? So there's no direct answer to that. What type of application? So I would say application which needs less compute resources that can exist or coexist with the Microshift binary, right? Because the Microshift itself would need a little bit of RAM as well as CPU power. Oh, I hope that answered your question, Srikanth.
Awesome. So I guess if there are no more questions, we can move to wrap up the event. Right. So first of all,
Prakash,
I think Prakash is having some.
Prakash, can you hear us?
I think he has gone offline. Yeah, maybe Humble. Maybe we can stop the recording.
Right. Yeah. Yeah, sure. Sure. Yeah.